Hello world, this is CS50, and this is an introduction to how CS50 has been teaching using artificial intelligence or AI over the past several months. My name is David Malan, and I teach this here course called CS50, which is Harvard's Introduction to the Intellectual Enterprises of Computer Science and the Art of Programming. If you would like to follow along with these same slides that you'll see over my shoulder, please feel free to take a photo or screenshot or pause at this point to use this QR code, which will lead you to a copy of today's slides. Now, CS50 is among Harvard's largest classes. Here on campus, we have some 600 undergraduates over the course of the fall, the spring, and the summer semester nowadays. We also have some 200 students each year through Harvard's Extension School, which is our continuing education program. And for the past 9 years, we've been collaborating with our friends down the road at Yale University in New Haven, Connecticut, where we have some 250 students taking the course as well. They primarily watch the course's lectures online, but with our own teaching assistants in New Haven and faculty, do they have sections or recitations, office hours, CS50 events, and more. For the past several years, we've also offered variations of the class through Harvard's Business School and Law School, CS50 for MBAs, so to speak, CS50 for lawyers, so to speak, which are focused more specifically on those particular demographics. And then, of course, as many of you know, the course since 2007 has been freely available as open courseware, which is to say anyone is free to take or to teach the class even using the freely available materials as well as technology. And indeed, through platforms like YouTube, do we have some 1.8 million subscribers. Through platforms like edX, do we have some 5.7 million registrants now to date. Now, CS50 itself, as many of you know, is quite substantive in terms of how much content and how much technology it covers. We begin the semester with a language called Scratch, which is a very friendly graphical language. We transition thereafter to roughly half the class in C, a more traditional text-based language. And then in the latter half of the course, do we transition to languages like Python and SQL and JavaScript in the context of HTML and CSS, so that at the end of the course, students are not only prepared for further studies in computer science foundationally, but also if they never again take another computer science course, we hope that they're well equipped to go back to their own fields of interest, be it in the arts, humanities, social sciences, natural sciences, physical sciences, or beyond, to apply lessons learned from computer science and programming to problems of interest in their own domain. But with this many students and with this many teachers, suffice it to say it's been a challenge and a goal to provide as much of a support structure as we can. Not only for CS50 itself, which many of you know by its open courseware name, CS50X, but over the past few years, has CS50 really evolved into a whole ecosystem of courses, an entire curriculum, particularly focused on introductions to various technologies and tools. But here are some of our screenshots of some of CS50's most recent courses, all of which, too, are freely available. In fact, if you're new to the community, feel free to go to edx.org/CS50, where all those courses and eventually more await. The course will focus most of our attention on today in this talk is CS50 itself, otherwise known as CS50X, which is available at this URL here. And for students and teachers in K-12, so to speak, middle schools, high schools, and so forth, do we also offer a version of the class called CS50AP, which high school and middle school teachers are welcome to adopt or adapt, whether or not participating in an advanced placement program for their own classes and students around the world. In fact, here's one of our favorite photos from a few years ago in New York City, where we brought together some 3 public and 2 private schools to have a CS50 AP hackathon, where students worked on their homework assignments or final projects. Pictured here is a visitation we had just a few weeks ago in Jakarta, Indonesia, where we worked with nearly 300 middle school and high school teachers there who spent the past 6 months taking CS50, perhaps like you, online, then to culminate in a professional development workshop where CS50's team went to Jakarta to meet all of these teachers, and in the coming weeks and months will they return to their own classrooms to teach CS50 in some form itself. And pictured here, lastly, are some of our students in Nicaragua holding proudly some of their CS50 certificates and Harvard pennants, which is a community, too, that we've gotten to know all too well additionally. So indeed, if you'd like to join those and more communities, please feel free to reach out after today at any time via outreach@cs50.harvard.edu. So the premise for today's talk, and really the motivation behind a lot of CS50's work over the past year, has been this premise, that ChatGPT and tools like it Bing Chat, GitHub Copilot, and the like are just too helpful. They are all too willing and all too deliberately designed to try to answer your questions outright. Now, in terms of the real world and in terms of solving real world problems and producing code, for instance, in industry, that's a great thing. I think we've seen evidence already between tools like GitHub Copilot and Bing and ChatGPT that there is potentially and invariably is going to be even more of a productivity boost. It will save humans time and it will amplify the impact of individual humans, much more so, for instance, than replacing them outright. It will amplify one's impact. But in the context of education, as most of you might know or remember, it might be nice to have someone hand you the answers to all of the questions you have on some homework assignment, exam, or the like, but that's certainly contrary to the whole point of learning in the first place. And so our premise and presupposition is that tools like ChatGPT out of the box, because they're either on or off, there's no settings really for these tools right now, are all too willing to just answer any and all of your questions instead of, like a good teacher or tutor, leading you to an answer. Rather, they tend to just hand it to you outright. And so what CS50's team set out to do over the past year was try to implement our own version of ChatGPT, if you will, building on top of the shoulders of these other giants, OpenAI, Microsoft, Google, and others, but imposing some pedagogical guardrails, so to speak. Ironically, trying to make these tools less helpful, putting a little bit of downward pressure on their default behavior of handing you all of the answers, all of the code that you might ask for. What we instead wanted to really do is implement more of a tutor, a good teacher. And so, at least with our on-campus students initially, and now all of our online students as well, in CS50 syllabi, it is not reasonable, that is, it is not allowed to use right now AI-based software like ChatGPT, GitHub Copilot, Bing Chat, or the like, that suggests or completes answers to questions or lines of code. So through policy, we simply disallow usage thereof. Technologically, there's nothing stopping, of course, students and teachers alike from using these tools. So we've tried to walk this line sort of ethically and educationally within the class to message where these lines are and which lines should not be crossed. But rather than just take away this very nascent technology, which is undoubtedly going to be useful and probably with us here on out, we do deem it reasonable, by contrast, for CS50 students to use CS50's own AI-based software, including the so-called CS50 Duck or Duck Debugger, DDB, which is a riff on GDB, the GNU debugger for short, which is now built into two of CS50's tools called CS50.ai and CS50.dev, which is to say students are asked not to use off-the-shelf tools like ChatGPT, GitHub Copilot, Bing Chat, and the like, but they may and are encouraged to use CS50's own tools that ideally do have those pedagogical guardrails in place. So how do we go about implementing this so-called CS50 Duck NY? Well, in computing circles and in the world of programming, as some of you know, it's been a thing for quite some time to use something called rubber duck debugging, or rubber ducking for short, whereby if you don't have a colleague, a teacher, a friend, a family member who knows more about programming than you should at least keep a rubber duck on your desk near your laptop or desktop or phone so that when you do have a question or confusion, or you have some bug or mistake in your code, you can at least hold up this rubber duck and talk to it, walking through verbally whatever confusion or problem you're having. And even though in the real world the duck really shouldn't be quacking back at all, squeaking maybe, but not quacking back, at least in that process of airing your confusion verbally, for so many of us, myself included, that proverbial light bulb eventually goes off atop your head and you realize, oh, that's what I'm doing wrong, because you realize in verbalizing the problem where you've perhaps gone astray. So years ago, we in CS50 actually implemented a virtual version of this rubber duck, because even though we hand the ducks out here on campus to students residentially, we have so many more students and teachers online. So we implemented rubber duck debugging, or rubber ducking, in the context of not only the real world, and pictured here is an unnecessarily large 8-foot duck that is often beside me on stage, in addition to the tiny little rubber ducks that we do give out, but we also implemented a virtual version thereof. Within CS50 for the past few years, we've used a free open source tool called Visual Studio Code from Microsoft, very popular in industry and also usable in educational context. And we implemented what's called an extension, like a plugin using some JavaScript code that CS50 wrote to create a virtual chatbot that takes on the same personality of a rubber duck. And so, for instance, for the past few years, if a student were to ask a question like this textually at their keyboard, I'm hoping you can help me solve some problem. Well, up until recently, as many of you might recall, all this virtual rubber duck would do would be to respond with 1, 2, or 3 quacks. And that's it. And the extent of the complexity here was that we had a little bit of randomness involved so that we would programmatically generate 1, 2, or 3 quacks. Now, this is not a scientific measure, but we have anecdotal evidence that just having the duck quack back at you textually actually helps solve a non-zero number of problems in the world. And a non-zero number of students were appreciative that just by going through the process of typing out their confusion, even though the duck was only going to quack back at them, they realized through that process of verbalizing or textualizing their thoughts where they had gone astray. And honestly, this actually resonates with me. On occasion, I've posted on websites like Stack Overflow or Stack Exchange more generally, which has been a very popular tool for questions and answers online. And I have probably not posted on Stack Overflow far more frequently than I have posted on Stack Overflow because I'm so worried about looking like a dummy to everyone on the internet by asking a question that maybe I shouldn't in retrospect, that I carefully write down all of my thoughts. I try to express what I have tried, what is not working, what the symptoms are, and so darn often does that proverbial light bulb go off for me as well. So if you too have ever sat down to write a post or maybe an email or a text message but not sent it because you realized, oh, wait a minute, I don't need to, that then is the beauty of something like a rubber duck. Now, some of our students online just a few months ago were sort of shocked to discover, literally overnight, that when they began to ask their questions in English or some other human language, literally overnight, a few months ago, did the CS50 duck start responding to them in English, and in some cases, other human languages as well. And this is all thanks to the work of CS50's team over the past several months, and certainly the work over the past many years of the OpenAIs, Microsofts, Googles, GitHubs of the world to make this kind of chatbot, so to speak, now possible. And so thanks to one of our teaching fellows' daughters in New Zealand, has the CS50 duck really been brought to life here, not only graphically, but textually as well. And so pedagogically, what our goals have been over these past few months and moving forward is really to provide with AI students with virtual office hours 24/7, so to speak. Office hours, for those unfamiliar, at least in college campuses, is an opportunity for a student to go meet with a professor or a teaching assistant or TA one-on-one or in small groups to just ask questions about the week's material or homework assignments or the like. 24/7, of course, is referring to the number of hours in the day and days in the week. And the goal then, through AI for us, has been to provide really an approximation of a teacher being available to students throughout the day, throughout the week, to ideally help get them over certain hurdles. And we're fortunate, frankly, in places like Harvard and Yale and college campuses and university campuses more generally, to have a lot of human resources and lots of teaching assistants in some cases, lots of humans. But so many places around the world and so many students around the world don't have access to those same resources potentially. And so the goal here too has really been to try to uplift as much of CS50's community as possible and ideally level the playing field, at least in terms of the support that is available to someone, whether it's on campus or now very much off. And here is sort of the holy grail for us, so to speak, whereby the goal technologically and pedagogically for us has been to ideally approximate a one-to-one teacher-to-student ratio. Because even places like here on campus, we might have 10, 20, 30 students assigned to one teaching assistant or TA. We have weekly sections or recitations where those relatively smaller groups of students get together, not just for CS50, but to discuss other courses as well. But if you start to do the math and you think about an office hour, 60 minutes, if you have only 6 students attending an office hour, be it the professor or with the TA, that's only, 10 minutes per student among those 6. And for so many students for whom CS, programming, even STEM studies, science, technology, engineering, and math are new, that's just not very much time at all. And so being able with software to approximate the idea of one of me for every of you, one TA for every of you, is a very exciting thing educationally. And even though admittedly there's a lot of potential downsides on the horizon for AI, the applications we are so excited about are indeed those within education. All of this work that you're about to see would not have been possible and indeed without our friends at OpenAI, Microsoft, GitHub, and beyond, and particularly CS50's own team here in Cambridge and beyond, including Rong Shin, Andrew, Patrick, Charlie, Carter, and more over these past several months in particular. So allow me to share on the whole team's behalf what it is we've been up to. So underneath the hood is this website, really this web service called CS50.ai. It's a domain name unto itself, but it describes really this architecture here, whereby over the past several months we've been building out this technology stack, if you will. Now, at the end of the day, a lot of this stack is built on top of services like Microsoft Azure, which is their cloud service, or OpenAI's own. Indeed, companies like these, as some of you know, offer generally what are called APIs. Application Programming Interfaces, which is like a tool that you can sign up for, sometimes for free, sometimes for money, to actually use that company's technology or services or data in your own software. So really, OpenAI, Microsoft, and others have done a lot of the hard work here, and we have done our best to layer on top of their work a pedagogical layer, if you will, including those guardrails. Architecturally, then, our system looks a bit like this, but for today, we'll focus really on the human component, the user interfaces that have really been now presented to students and teachers alike. So here, for the unfamiliar, is a link to CS50's programming environment nowadays. It's a web-based integrated development environment, or really text editor with lots of extensions built in, called Visual Studio Code. It's built on top of something called GitHub Codespaces, which is a cloud version of what are called Docker containers, which is to say when a CS50 student or teacher logs into a website, cs50.dev, we use GitHub's APIs to automatically create for you something called a repository, something called a code space, aka container, in the cloud on GitHub's infrastructure, so that what you see in your browser is a real-world programming environment. But what you don't have to do is install any software yet on your own Mac or PC. It just works in terms of day one. At the end of the semester, what's nice about VS Code nowadays is that you can, if you want, install it on your own Mac or PC. Sometimes requires a bit of technical difficulty in solving thereof, but much better to do that, we think, at the end of the course than, for instance, on day one at the beginning. So once you visit this website, you see a landing page not unlike this, and built into this same tool is this CS50 duck. And what we set out to do some months ago was try to put our toes in the water with artificial intelligence, or AI, trying to think about, all right, what would be a helpful but also relatively easy feature to implement using AI by writing software of our own on top of OpenAI's APIs. And again, OpenAI is the company behind today's ChatGPT. And so the first thing we did to put our toes in the water, so to speak, was could we write code to explain lines of code to students? So whether they've written some code, or they've downloaded some code, or copied some code from class, could we explain it to them line by line, as any good human could if they were to raise their hand or ask someone online? So we did this. Here is a screenshot of VS Code. Here is a screenshot of some code written in that language called C. And this code relatively simply prompts the human for their name and then prints out hello so-and-so based on what they've typed in. For a student new to programming, and certainly C, there's a lot of non-obviousness going on here. There's a lot of complexity and a lot of syntax. But what students can now do, as of the introduction of AI to CS50, they can highlight one or more lines of code. They can right-click or control-click. They can then select this option here, Explain Highlighted Code, which doesn't come with VS Code. In fact, Rong Shin wrote an extension to contribute this menu option to this here menu. And as soon as a student clicks that, within 3 seconds or so, do they have a ChatGPT-like explanation of exactly those lines of code. Now, to be fair, this example itself is not very complicated. A human, a teacher, could certainly answer this same question and explain these 8 lines of code line by line, but that would take a few seconds, a few minutes. They might not be awake at the hour the student has this same question, and so the power here is that all of this was automated and customized for this particular context or code. So that was actually relatively straightforward. And so the next feature we set out to do was a little more sophisticated. Could we advise students with AI on how to improve their code style, the aesthetics, the formatting thereof? Within CS50, because we're an introductory course, we have actually consciously disabled a lot of features that normally come with IDEs, or integrated development environments, or text editors like VS Code. So we disable autocomplete, we disable auto formatting, things that just in the real world and once you've taken one or more courses, yes, totally reasonable to turn on. But in CS50 as an intro class, we really want students to develop some muscle memory and actually understand why their code should look this way, how to make their code look this way. And then once that becomes boring and uninteresting, then they can automate the process, for instance, later in the course or after. So when it comes to style, we implemented a new and improved version of a command line tool that many of you might know as Style50, but we made it more graphical. And so pictured here is another screenshot of VS Code. Here is some more C code at top left. And for today's purposes, I'll stipulate it's pretty messy. It's all left aligned, and it's not very pretty printed or well formatted. So what students now can do in the top right corner of VS Code is they can click a button called Style50. And what this is going to show them now on left to right is on left what their code currently looks like, to right what their code should look like, and this built-in diff editor, so to speak, uses some red and green color coding to make clear what you should remove or what you should add. But even this, frankly, to new programmers might be non-obvious. What am I supposed to do? Why? And so also at top right now, there's this explain changes button, and if students click that, they similarly get a ChatGPT-like explanation of how and or why to make their code look from left to right as we've proposed. So again, something that any teacher who's available or awake could do, but here again is this approximation of a 1-to-1 teacher-student ratio available 24/7. But the next feature that we set out to implement, which is now generalizable away from CS50, away from programming code, and really I do think representative educationally of what teachers and administrators in schools will be able to do in the arts, humanities, social sciences, physical sciences, and beyond, not just in CS soon, is can we answer at least most of the questions that students are asking, for instance, online. Now, for many years, CS50 has used various tools and various social media to enable students to ask questions and get answers, either from classmates or from teaching assistants or from myself throughout the day. Of course, we are not always available. Of course, not all of those answers from classmates who themselves are only learning the material are necessarily correct. And so there's really been an opportunity here to try to answer all the more at scale and all the more correctly those students' questions online, both on campus and off. So what we set out to do here was implement within an existing third-party tool called Ed, which some of you might have used, and we use it very heavily here on campus. It's a question and answer tool that allows you to post questions asynchronously. You ask now, and some number of seconds, minutes, hours, days later, hopefully a TA or a professor will reply. So here, for instance, is a screenshot of a question that a CS50 student might ask, and we've anonymized them here as John Harvard, but it's representative of a student question. And this question is kind of a softball. It's kind of an easy question because it's very definitional. Quote unquote, what is Flask exactly? I mean, honestly, Google could answer this, Bing could answer this. So this itself was not hard, but it was our first attempt to see how well AI could do. Here now is a screenshot of how the duck actually responded to that specific question. So Flask is a micro web framework written in Python. It is classified as a micro framework because ... And let me stipulate, especially if you're new to CS50, this is a topic we introduce at the end of the class itself. This is a pretty darn good answer. Indeed, this is something that I, as a human, would ideally have written myself. But of course, the AI, the duck, was able to answer this question within seconds itself. And now for the technically curious, what's really happening is when a student asks a question via this tool called Ed, and they hit submit to post the question to the website, what we have done over the past few months as CS50 is we wrote some code, also coincidentally in a language called JavaScript, that intercepts the student's question, adds some formatting and some additional phrasing to it. We then send it to our own server via HTTP, and that server is CS50.ai, as mentioned before. We then relay that question in some form to OpenAI's server or Microsoft servers to actually use their underlying large language model, the technology that underlies tools like ChatGPT. CS50.ai quickly gets a response from OpenAI or Microsoft. We might validate the response or make some slight tweaks to it. Then CS50.ai passes the response back to the Ed tool, which itself is a different website. And all that happens within 3 seconds, and voila, the student gets an answer from the so-called CS50 duck here and now. Now, many of you have heard, of course, that AI is fallible. It's not always correct. I do think this problem will go further and further away over time as the technology gets better. But what we do right now is provide ourselves with opportunities to at least remind students that this technology is imperfect. So, for instance, here's another more sophisticated question about the Caesar problem set, with which some of you might be familiar. Students have to write code in C to implement what's called a rotational cipher, to encrypt or decrypt information. In this case, though, I'll highlight it, the student has asked a more nuanced question: is there a more efficient way to write this code? So this isn't quite as simple as answering a definitional question like, what is Flask exactly? This is now more nuanced, where the AI has to understand the context of the problem and the code that the student has written, including this here error message. And so in this case, here's a screenshot from the same CS50 duck in this same tool called Ed, which, for today's purposes, I'll stipulate, is a pretty darn good teacher-like response. Not only does the duck acknowledge what it thinks the student is trying to do, the duck also provides a few lines of code, but really just starter code, nothing that spoils the answer to the question outright. But the duck also reminds the student at the bottom here that this is very much experimental. I mean, even our software, as you might have seen at CS50.ai itself, is still in beta, which is to say still being developed. And we remind the student, quack, do not assume that my reply is accurate unless that you see it's been endorsed by human staff. Quack. Now, where is that referring to? Well, it turns out that this particular tool has a graphical button that humans can click to endorse other people's answers. Until recently, this was meant to be used so that a teacher or a TA could endorse a student's response to another student, to just validate that, yes, the staff approve of this answer, it is good and correct. What we have done is co-opt the same button to now signal to students that if they see that a duck's reply has been endorsed per this icon at top right by a human, then they should trust that it indeed is valid. So we might not endorse it within 3 seconds, but usually within minutes or maximally hours are we doing the same. Frankly, I think this is a short-term mechanism to avoid what are generally called hallucinations, where AI just sometimes makes things up by chance, but I think this is a problem that it too will start to go away and away as the technology only gets better. But for now, this is how we are at least partly mitigating this. So this then is the URL, cs50.ai, that anyone in the world with a free github.com account can access. In fact, you're welcome to try it now or later. But at this URL lives not only that architecture, that service that I referred to earlier, that's talking to the graphical user interface and talking to OpenAI or Microsoft. Also, there is a full-fledged chat interface. So CS50.ai itself has its own front end, its own graphical user interface that is very, very similar to ChatGPT by design, so that students no longer need to even post asynchronously their questions and wait some number of seconds for the duck or a human to reply. They can have full-fledged conversations with the duck, much like you and I can have the same with ChatGPT, Bing Chat, or the like. This chatbot, though, as before, reminds the students from the get-go that their response should be taken with a grain of salt. This here response reminds students to always think critically, so that at least for now, they're at least not in the habit of just assuming as outright fact something a computer is telling them. Here, though, is a question that will look even more familiar to those of you who have some programming experience, especially with Python. And it's representative of not only an interesting code question, but also representative of the amount of detail, or dare I say lack thereof, that students often include when asking questions of us humans or these ducks. So here is a bit of Python code that is trying to prompt the user for two integers, x and y. It is then trying to calculate the sum of x plus y. But the problem is not obvious from the student's post here, because all the student has noticed is, my code is not working as expected. Any ideas? So here's an example of a question, and it's barely that really the AI needs to understand from context, almost understand the code, it would seem, or at least recognize it as familiar to some other code the AI has been trained on, so to speak, thanks to lots and lots of input from the internet and beyond. And in this case, I'll tell you, the symptom would be this. If the human typed in 1 for x and 2 for y, you would hope that this code would print out 1 plus 2 equals 3 as the answer. Unfortunately, this code, as some of you might be realizing, actually prints out 1, 2. That is what looks like 12. And that's because, as the duck notices, it seems that you're trying to add 2 integers, but the input function in Python returns a string. That is to say text, not an actual number that you can perform mathematics on. And so when you try to add x and y, you're actually trying to concatenate the 2 strings, not add 2 integers. So the duck here provides students with just a couple of lines of guidance, but indeed lines that include Python's int function, which will indeed convert a string that looks like a number to an actual number. And so what we've seen now behaviorally among students is that most students are now interacting with the duck via this here synchronous chat conversational interface. Some of them a little too much, and in fact we adopted midway through the past few months this here heart system, a sort of HP system or energy system whereby you can only ask so many questions now per unit of time. And this is a knob we can turn to allow for more or fewer questions, but this is meant to really kind of chop off the tail end of excessive use educationally, we think of the duck. That is to say, we've seen some students online ask hundreds of questions per day, which honestly, I don't know where exactly the line is pedagogically between too few and too many questions. But in the real world, if a student were to ask a teacher hundreds of questions per day, it feels like that's the time, if you think back to high school or middle school, a good teacher would probably say, David, why don't you go back to your desk and think about this a little bit? And so what we try to do with these hearts is prevent students from asking too many questions too quickly at once, to virtually send them back to give it some thought. And frankly, nowadays too, this architecture is not free. APIs generally cost money, and even though it's free to students and teachers, our friends at Microsoft and OpenAI and GitHub and others are kindly covering through educational grants use of this system. We also just try to minimize the operational costs with this same mechanism as well. So to speak to the scale of this whole system, if curious, as of today, we're up to some 115,000 students and teachers who have used the duck over the past few months alone. That's roughly 20,000 prompts or questions really being asked per day, for a total of roughly 4 million questions so far. So even if you've just asked a few questions, you are in very good company among all of these others. We thought, though, we'd share now a little bit of the technical insight of how all of this works, because actually CS50's architecture is now retrospectively pretty representative of what other people in the world are now doing as well. Underlying a lot of today's uses of AI is a technical term known as a system prompt. That is to say, companies like OpenAI, Microsoft, Google, and others have made available to the world large language models, or LLMs, which have been trained on massive amounts of input, English text, code, text in other human languages, to try to recognize patterns so that when it is asked a question, it knows with high probability how to respond. The AI doesn't necessarily understand the question, but at least recognizes it in some form, and using tools like neural networks and other components of machine learning, so to speak, nowadays, AI is trying through these large language models to finish our thoughts for us or answer questions more concretely. But you can personalize them. You can customize their behavior by giving them what's called a system prompt, for instance. So out of the box, these large language models sort of speak English and some other human languages. They speak Python and some other programming languages. But you can give these AIs a personality or a scope of reference. So for instance, and this is abbreviated, here is what CS50's system prompt maybe in day 1 looked like, though now it's much, much longer and more detailed. We tell the AI, you are a friendly and supportive teaching assistant for CS50. You are also a rubber duck. And that phrase alone is sufficient instruction to get the generic AI to start quacking, really, and behaving like a rubber duck. We tell the duck further, answer student questions only about CS50 and the field of computer science. Do not answer questions about unrelated topics. Do not provide full answers to problem sets, as this would violate academic honesty. And so we're effectively programming the AI, if you will, through English. And so this is what has become known as prompt engineering, which is trying to come up with the English or the human language description of how you want the AI to behave. I do think this is a technique that's going to evolve quite quickly over time as these things get more featureful. But for now, you use English or your own human language to tell the AI how to behave. And in our case, after this so-called system prompt, we tell it, answer this question. And if you, the student or teacher, ask this thing a question, we essentially copy paste your question at the bottom of this system prompt, and your question is what the world would generally call a user prompt. That's what's coming from you. The system prompt is what's coming from us. Now, just a few weeks ago in the US and a lot of other countries was April Fool's Day, whereby lots of people tried to make funny jokes. And thanks to my colleague Rongshin, did we modify the system prompt of the rubber duck for just over 24 hours, as some of you might have seen, to behave a little differently. And so what Rongshin kindly did was edit our system prompt and still start with "You are a friendly and supportive teaching assistant for CS50. But he then added this text on April 1st. "You are also a rubber duck in Rick Astley's band." Importantly, you should always cheer up the student at the end by incorporating "never gonna give you up" in your response. Now, for the unfamiliar, Rick Astley and this particular song have become known as a meme on the internet, and the goal is to sort of trick people into watching a bit of its music video. So Rongshin kindly integrated this language into the duck's programming, if you will, so much so that if you, the student or teacher, were to ask a question that day with this system prompt in place, like "what is recursion?" you would get wonderfully an answer that we did not hard code. This was dynamically generated by the AI using just that system prompt alone, an answer like this. It's a powerful tool. And remember, I'm never going to give you up, so keep practicing and answering questions. An allusion to the lyrics in that same song. So what are the results now, pedagogically, operationally, that we've seen in just the past few months alone? Because we really are just beginning. Indeed, this is very much a beta, very much experimental, but already impactful, we dare say, in the real world. So in terms of usage, at least among our own undergraduates, whom we survey weekly throughout the course with questions, we know that 17% of the students in blue were using the tools, CS50.ai and the duck inside of CS50.dev, more than 10 times per week. 32% in green were using them 5 to 10 times per week. 26% of them were using them 2 to 5 times per week, and so forth, which is to say a super majority of our undergraduates, and dare say now our online students, really dove into this use of AI quite quickly as well. In terms of the helpfulness, this is now anecdotal and measured only based on students' own responses, not a more rigid measure, but 47% of students in blue this past fall found the duck-based tools helpful, very helpful. 26% more in green found them helpful, 21% found them somewhat helpful, and so forth. So again, not 100% across the board, but a super majority of students were already finding these tools in what we'd call like version 0.9. I mean, it's a beta. It's not necessarily done or finished. We're already finding them useful. Now, more quantitatively, we looked last summer, and this is work we'll continue in the coming months. We looked at a relatively small sample set of our first questions and smaller version of CS50 of students over the summer last year, when we analyzed the questions being asked by students via that asynchronous tool called Ed, and we analyzed with human eyes the quality of the duck's response, we came up with these measures. That in the very first version of the duck last summer, the duck answered 88% of curricular questions, content questions, correctly, and 77% of administrative questions correctly. So not as good administratively, but though by administrative we mean policy questions, deadlines, things like that, that frankly change every semester or every year. So it stands to reason that the duck was just outdated, because especially at the time, OpenAI's data set had been trained only as far as 2021, not 2023 data. But even 88% already out of the gate was incredibly strong. Curiously, though, and to share a more scientific finding here, in fall of 2023, when we had even more students taking the class on campus, it appeared at first glance that the duck's answers were only correct 39% of the time, a marked decrease. But this just didn't line up with reality as we perceive students' usage. There was no actual evidence to suggest really that the duck was erring nearly 60% of the time, but rather that students' usage of the duck was changing. These numbers here were entirely based on that asynchronous tool called Ed that, again, posted a response asynchronously for the duck or a human from the duck or a human. But what we found was that students' behavior was very quickly transitioning to CS50.ai itself, or a synchronous conversational version thereof built into CS50.dev, that is to say VS Code. So in fact, we noticed this as follows. When we looked at the data in Ed, this Q&A tool that we use both on campus and off, among our on-campus students over a year ago, in fall of 2022, students were asking, across 500 or so students in total, roughly 0.89 questions, or 1 question per student online during the semester. Not very high per student, but with 500 students, it certainly added up. The next summer, summer of 2023 that we looked closely at, they were asking roughly the same, 1.1 questions per student. But this past fall, when we deployed the CS50 duck in this conversational form, as well as in VS Code, the number of questions students were asking on campus asynchronously via that Ed tool for questions and answered dropped by 75% to just 0.28 questions per student. And so our working hypothesis is that students were asking most of their questions now conversationally, synchronously, so to speak, via the duck's own UI, and far fewer questions were being sent to Ed. Indeed, the questions that were going to Ed, we do think, were those more difficult questions, or questions that maybe the duck did err on, that were being escalated, so to speak, to Ed, because humans were keeping an eye, per the endorsed button and so forth, the Ed tool, but we were not keeping as close of an eye on the conversational bot. So we think the types of questions being asked by students were indeed becoming much more administrative, much more particular, that the duck itself wasn't answering conversationally. We look to at other impacts. On campus, we're fortunate to have lots of humans and lots of human support, both at Harvard and Yale. And so through office hours numbers, we also saw a difference. In fall of 2020 and in fall of 2022, when we had roughly 500 students or so per semester, we had some 50% of students attending in-person office hours, signing up by appointment for small group questions and answers with our teaching assistants. In fall of 2023, that dropped by 40-some% to just 30% attendance. That is to say, fewer students were taking advantage, funny enough, of those same human resources. We've omitted fall of 2021 because that was impacted particularly by COVID, but otherwise we think that this has been a marked change this year with the duck live and in students' hands vis-a-vis prior years instead. And some of our favorite anecdotal evidence that we've presented recently in a paper that we'll link to ultimately hereafter is some of students' own comments about the duck when surveyed on campus at term's end. One student noted that it felt like having a personal tutor. I love how AI bots will answer the questions without ego and without judgment, generally entertaining even the stupidest of questions without treating them like they're stupid. It has, as one could expect, an inhuman level of patience. And that recognition by a student really resonates with me, because I think back even to my own college days, graduate school days, when not infrequently I would go into a professor's office hours one-on-one. I would ask my questions, several of them sometimes, but I feel like more often than not, I would leave the professor's office hours nodding my head, saying thank you, yes, that cleared everything up, but thinking to myself, that did not clear everything up. I'm still confused, but I'd kind of overstayed my social welcome. Not because the professor didn't want me there, not because they ushered me out the door, but because I felt that there was some limit where, I was kind of thinking I'm the dummy, right? Imposter syndrome is a thing. Maybe I didn't really feel like I belonged there. And so the fact now that we have technology via which students can still access humans in many cases, but can alternatively have a much longer, much more paced conversation with an AI that's pretty akin to a teaching assistant is pretty enabling, I think, for clearing up all of our confusion. So much so that even before CS50's lectures nowadays, be it on campus or on camera, even I find myself using tools like this, or ChatGPT more generally, to go down intellectual rabbit holes, ask questions of the AI that I could Google or I could look up on Bing. But AI is getting pretty darn good at just hitting the nail on the head, so to speak, giving me the answer I want, therefore amplifying my productivity, my efficiency, so I can then keep my head in the space of preparing for class in that way. Another student this past fall wrote, the AI tools gave me enough hints to try on my own and also helped me decipher errors and possible errors I might encounter. And a third student wrote, I also appreciated that CS50 implemented its own version of AI, because I think just directly using something like ChatGPT would have definitely detracted from learning. And that too was our whole working premise, and indeed a lot of the motivation behind building CS50's own duck on top of these open platforms. Now, what future work and future impacts do we think lies ahead? Well, I think one on grades, both on campus and off. For instance, those of you who have taken CS50 are generally familiar with how we grade our programming assignments, at least, on 3 axes: correctness, design, and style. And for many years now, since 2012, have we automated correctness grading by way of a tool at the command line called Check50, which runs what are effectively unit tests or functional tests of a student's code. So we automated feedback on correctness years ago. Similarly, years ago, we automated feedback on style through the command line version of Style50, and more recently now the graphical version. And so we've already seen over the past 10 plus years that students' grades have been going up and up and up, certainly on campus as well as online. And this is independent of the sort of grade inflation you hear or read about in higher education more generally. This is a direct side effect of providing students throughout the week with iterative, if not immediate, feedback. And so through AI, what we do suspect is about to happen, and is probably already happening, though we've not yet measured it, is that the quality of the design, last most of students' code, will probably begin to increase all the more before they officially submit as well. Because if and when we use this AI to provide students with a Design 50 tool, which they effectively already have, because you could just copy paste your code into the CS50 duck and ask it, like one student, how could I improve this code, and get iterative feedback throughout the week, it stands to reason logically that if the AI, or really a teacher in general, is giving you iterative, incremental feedback back hour by hour or day by day, that hopefully your code or your homework more generally will be pretty darn good, if not close to 100%, by the time you actually submit. So if we then think ahead a few months, a few years, if everyone's getting 100%, like what does that really mean for assessment? Is there still an opportunity to help students distinguish themselves from some baseline measure of where they should be at a certain point? Is there any way we can distinguish just how strong or weak a student is in some topic after some number of months? Well, where we think this is going to be an opportunity to apply AI in other ways. We have already, CS50 here on campus, used CS50's duck, reprogrammed it with a different system prompt to try to train our teachers how to answer students' questions in person. We get the duck to behave, for instance, like a student who has some confusion in office hours, and they do role play with the human TAs. I think moving forward, what we'll likely do with students, meanwhile, is program the duck with really a different system prompt to have a conversation with students at the end, or maybe even weekly during the course, akin to yesteryear's oral examinations, which if never experienced might be one or more faculty sitting down very stressfully with a student in front of them, asking them questions about their field of study, about their thesis or dissertation, or some topic more generally. That's hard to do with humans, because you really do need a one-to-one ratio, if not a multi-teacher to one-student ratio to achieve that readily. But through AI, perhaps we can start asking our students here, all of you, or your teachers, you, questions about the material being learned, be it CS50 or anything else. Have you type your answers as quickly as you can, and then maybe in version 1 of this vision, we use humans to evaluate the quality of the conversation you just had to see how good your answers seem to have been. We can then sort of ignore questions that we think, the duck or the AI shouldn't have asked that, it wasn't a good question. And frankly, in version 2 of that vision, I would conjecture, is going to be just having the AI evaluate the quality of the conversation for you automatically and for us, so that you get this feedback loop, ideally week to week during the term, and probably at the end of the course as well, that really gives you a better sense of, one, where there are holes in your understanding, what you should focus your own time and learning on, and two, just how strongly you are exiting the course, whether indeed you've performed at the level of an A, so to speak, or a B, or a C, but not necessarily worrying, therefore, about these more marginal numbers that we accumulate during the week now based on these tools like Check50, Design 50, and Style 50, which themselves can evolve into more teaching tools than they are for assessment alone. So that then, over the past few months alone, is how CS50 has been taught using AI, thanks to CS50's own team and so many of our friends in industry around the world. This here is the title officially of a paper that we presented at the ACM SIGSE, Special Interest Group on Computer Science Education Conference most recently. So if you'd like to dive into more of the details of this here talk, if you look up this paper's title online, that should lead you to it as well. So this then was AI in CS50, and this, of course, is CS50.